Assalamualaikum warahmatullahi wabarakatuh. My name is Armithya Wisaksono from class 11-1, and today I will discuss 3 questions from the physics final exam. To find speed, the formula is V equals F times lambda. Because we don't have F, the formula for F is 1 over T, or period. We already have the wavelength, which is 8 centimeters. So, to find V, we use 1 over T times 8 equals to 2 meters second minus 1. So the answer for this is 2 meters second minus 1. B. A second wave Z has wavelength 8 and amplitude 2 millimeters at point P. Waves Y and Z have the same speed. For the waves at point P, calculate the ratio. For this, we use the formula intensity is proportional to A squared. We already have the amplitude of wave Z, which is 2 millimeters, and the amplitude of wave Y is 4 millimeters as shown here by the graph. So the formula is amplitude of wave Z square over the amplitude of wave Y square, which equals 4 over 16, which equals to 0.25. For ratio, we don't need the unit, so the answer is just 0.25. For the second question, I will do number 4. Number 4A, describe the Doppler effect. For the second question, I will do number 4. Number 4A, describe the Doppler effect. The Doppler effect is the change or difference in the observed frequency when the source is moving relative to the observer. B. A car is traveling at a constant speed towards a stationary observer. The horn of the car sounds at a frequency of 510 Hz, and the observer hears a frequency of 550 Hz. The speed of sound in air is 340 meters second minus 1. Calculate the speed of the car. To calculate the speed of the car, we will use the formula frequency of sound times the speed of sound over the speed of sound minus the speed of source. The frequency of the sound is 510 times 340 over 340 minus x, since we don't know the speed of the car. We can cross multiply 340 times 510, which equals to 173,400, which equals to 500 times 340 minus x. Now we need to make x the subject of this equation. Now we're going to multiply 550 into the bracket, so that will equal 187,000 minus 550. Now that we have this equation, we will flip this around, and now we will move this to the left side. Minus 178,000 equals to negative 550 x. Now make x the subject, which will equal negative 13,600 from 173,400 minus 187,000, it equals to this, divided by minus 550. And the answer is 24. And the decimals are 7272 and so on, which equals to 25 meter second minus 1. And there is our answer. For the third and final question, I will discuss number 5. 5A, state the difference between progressive waves and stationary waves in terms of the transfer of energy along the waves. The difference is progressive waves transfers energy throughout the medium, while stationary waves do not transfer energy because the energy stays trapped between the nodes. B. A progressive wave travels from left to right along a stretched string. The figure below shows part of the string at one instant. P, Q, and R are 3 different points on the string. The distance between P, R is 0.48 meters. The wave has a period of 0.020 seconds. The wavelength here is shown from Q to this point here. We have the distance from P to R, which is 1.5 waves. So to get the wavelength, 0.48 divided by 1.5 or 1.5, which equals to 0.32 meters. And that will be our answer. Calculate the speed of the wave. For the speed of the wave, we will use V equals F times lambda. Since we don't have F, and F equals to 1 over T, we can simply use V equals to lambda over T. 0.32 from the answer from this question over 0.020, which was given in the question, which equals to 16 meters second minus 1. And that will be the final answer. Determine the phase difference between point Q and R. One peak is 180 degrees. For one wavelength, 360 degrees. Here we have one wavelength. So that is already 360 degrees. Oops. Since this is a peak, this is half a peak, that means 180 divided by 2, which equals to 90, which gives us 450 degrees. This concludes our discussion of 3 physics questions. Thank you, and wassalamualaikum warahmatullahi wabarakatuh.